cover note cards 43, 44, and 45 in one podcast. They should be pretty simple note cards. We're going to start talking about inverses and how to find them, starting here with note card 43, how to find them with their x and y values or given a t-chart of the data. Number one, it says to find the inverse of a function, switch the x and y values. Pretty technical here. Not really. If we have an example here of a function a, we have x's are 3, 6, 5, and 9. We have y's are 2, 1, 8, and 2. And so to find the inverse of a, you simply take the y's and make them your x's, and then take your x's and make them your y's. And now we have the inverse of a right here by flipping the x's and y's. That's pretty simple stuff, hopefully. Number two, a one-to-one function. A one-to-one function is a function where the x and the y values don't repeat. We already know that in order to be just a function, that the x values are not supposed to repeat. Well, to be a one-to-one function, the x and the y values cannot repeat. So here's an example of a one-to-one function. Our x values don't repeat, our y values don't repeat. It's a one-to-one function. So what's so special about a one-to-one function? Well, maybe you can already see that if the x and the y values don't repeat, that if you have a one-to-one function here, our x values don't repeat, our y values don't repeat, and so when I find the inverse of that function, the inverse is also a function because the y values that we're not repeating here are now the x values, the independent values here, that are not repeating. So that's what a one-to-one function is. Continuing on to note card 44. You're going to need to use your calculators for this note card. What we have, it says to find the inverses graphically. Number one, set up your window. Then it says Zoom 6 usually works. You always want to start off graphing a function using Zoom 6. That's the standard viewing screen. And then go from there if you can't see it after that point. So we're going to use the Zoom 6. We want to enter the equation into the calculator, and we want to put in y1. We want to enter the equation, or the expression rather, 2x plus 1. Then we want to go to our table using second graph, and we want to write 5 sets of ordered pairs here. So let's see what we've got. So I've got 2x plus 1. And I want to do Zoom 6, standard viewing screen. I see my function. And now I want to go and look at all the points that are on this line. And so I'm going to go to my table, and I get there by hitting second graph. Now you could put all kinds of different points in here. For this note card, for everyone to have the same note card, and for every example that you have that you can do this with, I want you to use the values for x, -2, -1, 0, 1, and 2. These are good values to use if these values exist within the domain of the function, because it will give you a symmetrical view about the origin. Another good reason to use these points is because the graphs that you're going to be given on most of your worksheets, quizzes, or tests are small graphs, and these will be the ones that would fit on those graphs. So we need to write these ordered pairs. And I'm going to skip down a little bit so I can go ahead and bring my graph up to view. So for number 4, my ordered pairs that I'm going to write that are on your blanks on your note card for number 4, I'm going to have -2, 3, or I'm sorry, -2, -3. -1, -1. 0, 1, 1, 3, and 2, 5. What I want to do now is I want to plot these points and sketch the graph of this line. -2, -3.
Excuse me, we need Kelsey O'Shorn to the Eco Depot, please.
Okay. -1, -1. 0, 1. 1, 3. And 2, 5. Then I want to sketch that line through there. And so that's the function of 2x plus 1. Now on your note card, it tells you for number 6 to reverse the coordinates of these points. So for number 6, you would have -3, -2, just reversing these, making the xy and the yx. -1, -1 stays the same. Then I have 1, 0. Three, 1. And 5, 2. Then I want to plot those in another color. Now, for those of you that may not have colors, what you can do is you can use a pencil for one color and a pen for another color. So I've got -3, -2. -1, -1 is there. 1, 0. 3, 1. And 5, 2. And I want to sketch that function. Now the next thing we want to do, if you don't have more than one color and you used a pencil and a pen for your two colors, we want to actually have the line y equals x here. We want to graph that. And if you don't have more than those colors, you can graph the line y equals x as a dotted or dashed line. And so the line y equals x looks like that. And so what we should see here then is when I'm looking at the line y equals x, which is I'll highlight it in blue. When I'm looking at this line y equals x, you should see that my two functions, 2x plus 1, the black function, and the inverse, this color here, they're reflections of each other in the line y equals x. And that will happen every time when you're looking at the graph of a function and its inverse, or just two relations that happen to be inverses of each other. Okay, so you should be able to see that reflection in the line y equals x. And so if you're having a hard time seeing that, this portion of the black line up here is a reflection of the line y equals x down here. And this portion of the black line down here is a reflection of the line y equals x on this piece here. But basically, when we're looking at them graphically, the graphs of the inverses, they should be reflections in the line y equals x. And then finally, let's move on to note card 45. It's pretty short and sweet and simple. If you recall the vertical line test is a test that we use a vertical line to determine if a graph is a function or not. And basically, if you can draw a vertical line on a graph, and if it can cross more than one point at any place, then it fails the vertical line test and it's not a function. That's a review. We're going to talk now about the horizontal line test. The horizontal line test has the same basic ideas, except we're obviously using a horizontal line. And we're testing to see whether or not a function is one-to-one. Now remember, if a function is one-to-one, that means the x's and the y's do not repeat, and its inverse is also a function. And so using the horizontal line test, which means that if I can draw a horizontal line anywhere on the graph, and if it crosses at more than one point, then it fails the horizontal line test and it's not one-to-one. However, if I can draw a horizontal line, let's just look at these examples quickly. This function right here looks like some type of a quadratic. You should be able to see that it's going to fail the vertical line test because I can draw a horizontal line test because I can draw the horizontal line in many different places and it's going to cross at more than one point. So it fails the horizontal line test, which means that this function is not one-to-one. Now looking down here at this cubic function, I can do the horizontal line test, and when I do that, no matter where I draw it, you should see that it's only going to cross at one point. Now it might look right here like it's crossing at one point, but if you remember from when we were studying how to graph polynomials on a triple root, or a cubic here in this case, on triple root, the graph kind of approaches the origin at this place right here, and it kind of flattens out and goes off in the other direction. That doesn't mean it's crossing at more than one point. That means there's a triple root there at x equals 0. So it's only going to cross at one point, therefore it passes the horizontal line test. So this function is one-to-one, which means that if I found the inverse of its function, it would also be a function. And that pretty much wraps up these three note cards, 43, 44, and 45. Hopefully you found that not too difficult.